So now what we're going to do is we're going to begin talking about some of the specific methods and techniques that are used in neuroimaging. There's sort of a breakdown of what we can call the taxonomy or the relationships between various neuroimaging technology. You'll notice up in the right-hand corner up here, these are going to be techniques that we're going to talk about, but they are important, but they're not technically imaging because they don't actually take images. They're more about reading electrical signals from the brain. The actual imaging techniques are based on three primary divisions: external ionizing radiation, internal ionizing radiation, and non-ionizing radiation. So all of these are based around either putting in radiation into the body or applying it externally. But the idea is that we rely on tissue radiating energy to form pictures. And the main sort of distinguishing characteristic is this idea of what we call ionizing radiation. So ionizing radiation is the kind of radiation that we are taught to be afraid of or nervous of, or that is dangerous. Ionizing radiation has high energy levels. It comes from the spectrum of light, right? Light is not just the visible light that we can see, but has energy waves that extend into non-visible light. The higher the energy is, the shorter the wavelength. We move through ultraviolet, X-ray, gamma radiation, and the longer the wavelength, right, we move into lower energy, and we get into things like infrared, microwaves, and radio. So anything that is sort of pushing above the visual spectrum in terms of energy is going to be ionizing. In this sense, it is so energetic that the energy can actually knock parts of our atoms off, electrons or other subatomic particles. And this can actually break down our DNA, causing mutation and ultimately cancer over the long term, or even complete organ failure if we get a large enough dose. As we move into the lower energy states, it's non-ionizing radiation. It's not going to be energetic enough to do damage to the body. All right, so ionizing radiation is something that we have to be careful about controlling the dose of. You can't get too much ionizing radiation or it will kill you. Whereas the non-ionizing radiation, there is nowhere near the concerns in terms of long-term damage. There are some other concerns, right? Because absorbing the energy, for example, heats up the body. That's how microwaves cook your food, is the water molecules absorb the microwave radiation, which causes them to become more energetic and release heat. Right? So when we absorb these low energy waves, the body, for example, can heat up. And when we talk about non-ionizing imaging, that's one of the concerns, right? Are we basically microwaving our subjects? But it is far less of an issue for multiple scans and repeated scanning than when we're dealing with ionizing radiation, where there is a significant concern about long-term risks. So again, ionizing versus non-ionizing is the first major subdivision. And then we're going to talk about external versus internal, right? So external is when the ionizing radiation is applied externally. There's a source for the radiation that is basically shot at the body, and there's some sort of detector that is looking to detect what kind of ionizing radiation mixes through the body or not. Right? These are most commonly done through X-rays. Right? Internal ionizing radiation is where we actually inject the person with something that is radioactive, and we're looking for the radiation that is coming from out of the body, and that has some very specific and fascinating imaging applications. And then non-ionizing radiation, the much safer form, but also much newer form, is commonly the magnetic resonance imaging, and we will be talking about that as well. So just a brief tour of the taxonomy of neuroimaging methods and how they relate to ionizing radiation. All right.